Building the ISA server network infrastructure. Well, it's time to take a look at how the ISA server sees your network. Now, we're going to see a ton of new features of ISA Server 2004 in this section as we take a look at ISA Server 2004's view, or I should say new view, of multiple networks. And inside of that, we'll take a look at the default networks, because ISA Server now recognizes more than just the internal and external network. That was all the ISA Server 2000 could recognize. Now we have mini networks, unlimited networks that we can recognize and choose different treatments between. So we'll talk about the default networks and then talk about how to configure additional networks and everything that goes along with that. Network sets, chaining multiple networks together using something known as web chaining. We'll get into all of that. We'll also look at the network rules, which is huge, huge. It defines everything that allows each network to access each other. Without the network rules, nobody can access anything. Now finally, we'll talk about network templates, which are this is a picture of a network template over here. It's a flyby, easy to use way to get your ISA server up and running faster than ever before. Well, let's start off by taking a look at how ISA Server 2004 views multiple networks. I think this stuff is very valuable for people that are new to ISA Server. However, I think it's more valuable for those people that come from ISA Server 2000 because it will shift your paradigm a little bit. This is some features we all longed for in ISA Server 2000 but didn't get until ISA Server 2004 came about. So take a look. First off, ISA Server no longer uses the local address table, the LAT, to define trusted versus untrusted networks. As a matter of fact, since ISA Server 2004 has been released, there's no more concept of trusted networks. Essentially, every network is untrusted, and that means it only has the access permissions that you give it. You see, if you didn't come from the ISA Server 2000 world, ISA Server 2000 had a LAT, which defined the internal addresses, and those were the holy grail. Everybody was like, oh, the internal address, we love them, we trust them, they are allowed to do whatever we want. The other problem is that with this LAT, the only thing that you could do is when you went from a trusted network to an untrusted network, is you could only do network address translation. Meaning, if I was going from the inside to the internet, NAT would occur, and that's okay normally. But if I went from the inside network, which is trusted, to maybe a DMZ, which could be untrusted, NAT would occur. And maybe I don't want network address translation. So ISA Server 2004, look at this, allows routing or NAT relationships between any network that you want. I could route from my internal network to the internet without changing any addresses through NAT just fine by defining a routing relationship. I can route from the DMZ to my internal clients. I could route from one of many different networks that ISA Server manages to another through the ISA Server. Furthermore, I can define NAT relationships between trusted networks, something that was not possible in ISA Server 2000. In this version of ISA Server, it has become a true multi-interface firewall. Multi-network firewall, I think, is the more accurate term, in the sense that every network is treated as its own entity, allowing us to put whatever permissions we want wherever we want. It's pretty powerful. Now, ISA Server 2004, the firewall itself is seen as a unique network. Oh, so cool. We can actually, and it's already defined, see the ISA Server 2004 box itself as its own network. What's that mean to us? It means that we can protect our ISA server from attacks from the inside, outside, and upside down. From any network that's attached to that, we can restrict and protect the ISA server. See, in the ISA Server 2000 world, it was kind of like, hey, internal network's gold. If they want to get to the ISA server, that's okay, because we trust our internal folks. Ha! Yeah, until one of them destroys it. I mean, it was a dangerous thing. So now it is a true firewall, which allows you to define your own policies for the ISA server itself. And I think you saw a little bit about that when we went into the system policy area. Finally, we have the VPN clients that are treated as a separate network altogether. Before, they would actually become part of the internal network. When they VPN in, they are part of the LAT. And that that was a little bit dangerous because VPN clients can actually connect to other networks at their location and move traffic from an outside untrusted network into our internal network, and the ISO server would never think a thing about it. Nowadays, we have the VPN clients as a separate network, and we can even quarantine them if they don't meet our specific security requirements. Those quarantined VPN clients are one of 5 different default networks that come with ISO server. And you can see a laundry list of them right here. Localhost, internal, external VPN clients, and quarantine VPN clients. But I think it's a little more effective if we see it in the live ISO server interface. I think exploring those networks this way will allow us to get a little more familiar with configuring the ISO server through the interface. So I brought up the management console, expand the ISO server, expand the configuration, and I'm going to click on the networks area. This gives us a visual of all the networks that ISO server knows about. And right here we have, external, internal, local host, quarantine VPN clients, and VPN clients. All 5 of the ones that I was just mentioning on that slide. Now over to the right you can see a good description of what each one of them are. But just by the name you can really get a good idea of what they entail. Now this identifies each network to the ISO server and allows us to apply individual configuration settings to those networks. For example, one of the things I need to fix, you can see my internal network right here is all these ranges, when in actuality I only have 192.168 network. So I'm going to right click on it, choose the properties, and also we have our little bar over here. And I can click on the tasks and I can modify one of the individual settings that way. But I'll click on Edit Selected Networks. But what I want to do is I want to modify the addresses to be more accurate for my internal network. So I'm going to say the only addresses available on the inside are 192.168.0.0 through 192.168.5.5. And when I say 192.168.5.5, I really mean 192.168.255.255. So I'm going to go ahead and click on OK on that window. Hit apply. So now it's actually applying all of those settings to the ISO server and modifying that internal address range. The reason why I'm doing that is, first off, I want it to be a little more accurate. And second off, I'm going to start creating additional networks for this ISO server. And that will allow me to have more ranges that I can use and I can assign addresses to so I can pretty much treat them differently. So I think you guys got the concept. These are the networks that ISO server relates to. External means anything that is outside of this network. Now, does that mean the internet? Well, it could, unless you had maybe another firewall, maybe a third-tier firewall, if you will, that goes between the ISO server and the internet, and you have kind of a back-to-back configuration. So it could be like a DMZ kind of thing, or it could be the direct internet. And if you look at the properties for this, there's not too much there because these are the default built-in ones. Internal, you have some definite properties because you can tweak all the different client settings, and we'll get into what each one of these are a little bit later, but I can tweak all those settings for that. Local host is the ISO server itself. Quarantine VPN clients and VPN clients encompass these guys out here. Now, let's say that we want to add a new network inside of here for the ISO server. How is that possible? Well, there's a couple ways. I can use my little swoosh bar and hit create a new network. Or if you'd like to stay away from the swoosh bar, I can go ahead and right click on network, hit new, and choose network. So let's say I wanted to create a, maybe, let's come up with an example. Let's say I've got some scandalous users. So I'll put scandalous users. And I want to create a certain internal network that the scandalous users will be assigned to that maybe have stricter restrictions than the normal internal network. Now you can see when you're creating a new network, you have 4 different kinds you can set up. Internal perimeter, which is kind of like a DMZ. VPN site-to-site network, which is going from a local site to another site, and it's establishing a VPN between them. Or an external network. Now because the ISO server allows us to configure each one of these networks as untrusted, these names are pretty much just for accounting purposes, and so it can look good on a picture and that kind of thing. Setting these things up, you actually have the same properties available to you on just about every single one of these networks. So if I create an internal network for our Scandalous users or a perimeter one for our Scandalous users, it really will be the same. It's just kind of an accounting thing, a good name to assign to it. So I'll say internal users, and now it's saying what IP addresses do those internal users start with. Now I can click on add and manually type in ranges, or I can choose add adapter and select what adapter connects to them. Now in this case, my ISA server is connected to a router behind it that actually has multiple subnets. So I'm going to create a subnet on that router for the 10 addresses. We'll just say 10.0.0.0. So I'm going to add a range, but I can also choose on add private. Isn't that so handy? Look at that. That's awesome. I love when Microsoft does stuff like that. It's like, hey, here's their little menu, and you can just say, I just want to add that range. So I could manually type it in, or I can just add private and add that range. So all of the IP addresses in my network that start with 10, they're Scandalous. So I'm going to click Next, and right there it says, okay, I'm going to create this internal network called Scandalous Users, encompassing the addresses of 10.10 or 10.0.0.0 through the end of the range. I click on Finish, Apply. This configuration goes through, and then I should have a new network that my ISA server knows about. That will be the Scandalous users. Now, at this point, first off, you can see the network diagram doesn't update. This network diagram does not reflect reality. It's more of a network template, and I'll get more into the templates a little bit later. But don't expect new. That would be a cool feature if they had like a new network's like, phew, it appears for my Scandalous users. But that's not there. The big thing about this is now I can apply different settings for these users and different rules for these users as opposed to everybody else. Speaking of rules, let's take a look at this Network Rules tab over here that defines all the rules for all the networks that we have. Now there are some default rules that are already in there that allow our ISA server to work without much happening. Now this is a major tab to remember because there's so many times I've set this up and forgotten to do the rules. For example, we looked early on when we looked at setting up ISA server at this firewall policy, and we saw there's a default rule to deny all traffic from all networks, and that was the reason nobody could access anything. And all we had to do to get our internal clients to access the outside world was to define this all access firewall rule that allowed all outbound protocols from all internal networks to all external networks for all users. That immediately allowed them to access it. But the only reason that worked is because there is a rule in place by default, it's this one right here, that allows internet access that defines a NAT relationship between internal clients, Quarantine VPN, and VPN clients to the external world. Now, without this rule in place, it doesn't matter how many firewall rules we define, nothing will happen. This is one of the areas that's so easy to forget. And as of right now, I mean, our Scandalous network will not be able to access anything even if we defined a firewall rule allowing them through. We first need to define a network rule which gives us the ability to set up a routing relationship with other networks or a NAT relationship with other networks. And here's the key point. Our networks will not be able to access anything unless there is a network rule defined for them. In the Cisco world, I would call this a routing table. Pretty much a routing table for ISA server telling it what to do when certain networks access others. And take a look. Let me bring out my swoosh tab. Swoosh. And it says right here, create a new network rule. So I click on that, get our wizard popping up, and I can say Scandal to internet. And I'm going to say this rule applies to traffic from these sources. Click on add. Now underneath here I have my new network that I've defined, Scandalous users. Now you can see we have many other default networks that are in here already. The Anywhere network, the IPsec remote gateways, and so on. And we'll get into all of these and how we can create these a little bit later. But for now I'm just going to add my Scandalous users. Hit next. Now we come to the destinations. Notice source and destination. And click on add. Now the network I'm going to allow them to access is external. Add that in there. Hit close. Next. Now the big question. when they go from internal or the scandal network to the external, do you want to use NAT or do you want to route them? Now, if we route them, we will have a bunch of 10 addresses ending up on the internet, and our internet service provider will drop them. 10 addresses are private ranges for the inside of our network. So what I'm going to do is I'm going to use NAT. Click NAT from our scandalous users to the network, and I hit finish, whoosh, and apply. That immediately allows them to access the internet. Now here's the great thing I get so excited about. What happens if our scandalous users try to access the internal users? Nothing. Absolutely nothing. They get dropped because there's no rule, routing or otherwise, that will allow the scandalous users to access internal users. We've just defined one that lets the scandalous users access the external network or the internet access. Other than that, they are restricted from everything. Make sense? That's the idea of network rules. This is a very cool new feature of ISO Server 2004 that allows you to define security policies between any network in your environment. And I want to make sure I hit the rest of the network rules with you. Let me scoot this over a little bit just so I have a little more real estate on my screen. I want to hit the rest of these network rules with you because these are the default ones that ISO Server comes with. You can see first off, local host access. The rule is route from the local host, and who is that? That's the ISO server, going to all networks. So that means any interface on the ISO server will route to any one of these other networks. So I can ping, I can do anything that's not blocked by a firewall policy rule using the system policy from the ISO server. So all routing is defined there. VPN clients to internal networks, a routing relationship defined, ooh, look at this, from quarantined VPN clients and VPN clients to the internal network. So that allows them to access our internal network. Now this is the one that I just defined, scandal to internet. But down here we have internet access. We have internal quarantined VPN clients and VPN clients to the external world. Now I have to answer the question that I'm sure is running around many of your minds right now. What's up with those quarantined VPN clients? I thought they were quarantined. Aren't they restricted from accessing anything? Well, by default, no, they're not. And you can see that right here in these routing rules. Quarantined VPN clients are just the same as VPN clients. Truth be told, Microsoft just created that category of network so that you can have those clients and manipulate those clients later on if you choose to do so. But by default, it's more of a placeholder than anything, just to let you know, hey, they're there. There's actually not too much functionality right now in ISO Server 2004 out of the box that will allow you to do too much with quarantine VPN clients. Now there's already been people that have jumped all over this and have written other applications and features that we can add in there. For example, there's one of the MVPs for Microsoft. Those are the key players, I guess you could say, at Microsoft. I don't know how to pronounce his last name, but his name is Frederick Isonoff, E-S-N-O-U-F. And he's actually written a VPN quarantine application that you can add on here that gives you different treatments for these guys, because out of the box, ISO Server doesn't really do too much with them. So that just gives you an idea of those clients, because I know a lot of people wonder, well, what's the difference between this and this? Not too much out of the box. But you can see these default rules that are in place which define the NAT and routing relationship between the different networks that you have. Now there may be times where you want to apply a single network rule or a single firewall policy to a whole group of networks, and that's what the network sets are for. Network sets group multiple networks that you have created together. Now by default you can see there's two built-in ones. There's all networks and localhost, which includes all networks and the local host, which is the ISO server. It just says predefined network sets cannot be modified, which is what that is. All protected networks is the one that includes all networks except for this external network. And you can see that we have a type definition right here of exclude on both of those. That'll make more sense when we create a network set. Let's go ahead and do that together. I'm going to go ahead and click on create new network set, and I'll go ahead and name this I've got my internal networks, which is internal and my scandalous users, and I'll say not VPN. So I'm going to say internal without VPN. Just, just as an example right here. And I'm going to say, look at this. This is the big choice you have to make. This network set includes all selected networks or all selected networks except, or I should say all networks. I'm making this more confusing than it is. Includes all networks except the selected networks. Now, in this case, I'm just going to say it includes all selected networks. Wapow, wapow. And I've selected the internal and scandalous users, which are my true internal networks. Choose next. That's it. From there, I now have this internal without VPN network that includes the internal and scandalous networks, and you can see the type is include. Now, that makes these two make a little more sense, because if you look at them, it says all protected networks. If we go to the properties for that, it says this excludes these selected networks. So it's saying everything but the external network, and you can't modify it because it's a built-in one. But that's how it can do this. Even as you add more networks, it's still included in this all protected network group. So that network set, you can define as many of them as you want, and then apply network rules, firewall policies, and many of the other things that we'll see to the set instead of individual networks. The last tab that we see on here is web chaining, and we'll talk about this more later on in the series. However, while we're here, we might as well discuss the main use of this. Web chaining is useful in larger ISO server environments where we have maybe multiple branch offices going to a central location and then connecting to the internet. Matter of fact, let me draw up a picture of this so you can see it. A situation where we're using web chaining might go something like this. I might have a few branch offices, let's say, maybe 100 users or so, or maybe less than that, 50 users or something. So I've got my branches. I'll just put B. Now all of these maybe have frame relay connections or private T1 lines or something like that, going all to a centralized location. I'll put a C there. A central site, maybe you just have routers terminating those connections. It could be anything. Maybe DSL lines over VPN, who knows. But this is the one that has the high-speed, maybe T3 line going off to the internet. Well, at each one of these branch offices, I could install an ISO server, kind of a downstream server is what this would be seen as, that services all the clients in each one of these offices. At the central office, maybe we have an array of ISO servers, multiple ISO servers put together, and that is servicing the central site and these branch offices because it's connected to these routers and managing the connection to the internet. What web chaining is I can go ahead and have a client down here that goes to cbtnuggets.com. That request can be configured to be sent directly up to that ISO server in the chain. The ISO server in the chain checks its cache and says, nope, I don't have it. Let's grab it from the internet. So it grabs it from the internet, downloads the content, caches it, sends it to the branch office, who caches it, and sends it to the clients. Now, the next time a client in this office requests it, it only goes to this server and returns a response because it's cached. But now with that upstream server, I can have a request go, hey, I need cbtnuggets.com. Oh, I don't have it. Let me check up here. Oh, I've got it. Boom. Respond just like that, and you didn't use any of your internet bandwidth. In larger organizations, this kind of design, this web chaining scenario, becomes a definite reality for bandwidth savings because your branch offices expand larger and larger and larger, and you don't have to purchase an internet connection for each one of them. They just can connect back to the central site. I've seen this a lot of times. For instance, the city of Phoenix right now is converting their whole network to a Metro Ethernet connection. That means that, for instance, we have Child Protective Services under City of Phoenix, the Sheriff's Department, all these different groups that all connect together under a single authority, all tying through Metro Ethernet, as in the Sheriff's Department may not have an individual internet connection. Child Protective Services may not have individual connection. Although they are separate administrations and have separate IT administrative staffs, they could have a central site, maybe the largest building that has all the internet connectivity, and an ISO server set up just like this to where you don't have to purchase a monthly reoccurring cost for an internet connection for each individual division in the city of Phoenix. To configure web chaining, you would typically have a much bigger picture than what I have right now, a single ISO server. But you can see the last rule. This is the default rule that says, for all networks and the local hosts, just retrieve the request directly from the internet. There's no real chain set up in that, and that's why this is the default rule. So, whoosh, outer sidebar comes. Create a new web chaining rule. Now it's going to come up and say, what do you want to name this rule? And we'll say, bigger network than I have right now. And it says, this rule applies to traffic sent to these destinations. Now imagine, let's use our imagination here, that the ISO server that I'm sitting on is one of the branch offices that I just described in that picture. And I want to send all my web requests to an upstream ISO server, maybe in the central site, before I forward it to the internet. So in this case, I would say traffic sent to these destinations, that'll be external. Anytime somebody tries to access the external network, go ahead and put in a web chaining rule for them. And that web chaining rule says, don't receive it directly from the destination. Don't go to the internet. Go to an upstream server. Now, we can actually have authentication credentials that are passed, and you'll see that coming up. Or we can just say redirect it to this site. Maybe if there's some other server that's not a directly upstream server. It could even be a non-Microsoft server, like a Squid server on Unix or something like that. So I'll just say an upstream server, assuming we're using a ISO server. And right there it comes up and says, what server is that? Now I can browse if I have a larger array of servers, and I only have one server in my farm right now. We'll talk about arrays a little bit later, well actually much later when we talk about the Enterprise Edition. But I can say, the upstream server is actually up at, we'll say, why is my mind not working? Okay, there it is. isa04.cbtnuggets.com or something like that. Maybe that's the upstream server that I'm sending that to, and I can even authenticate if it's requiring authentication for those kind of requests. And at that point it says when the primary route is unavailable, meaning this one right here, the one going to isa.cbtnuggets.com, what do you want to do? Do you want to ignore the requests, retrieve the request directly from the specified, meaning go to the internet, or route requests to an upstream server? So that's just saying maybe there's another web chaining rule that you have second in your list that you would like to use instead. Well, I'll say, you know what, I only have one web chain, so if not, go ahead and use your internet connection, and voila, we've created this bigger rule now that will route any external request to an upstream server. Now, obviously, I don't have that upstream server, so I'm going to just discard all my changes that I've made, which will erase that web chaining rule and get me back to the default. That's the web chaining world. Now, the last thing I want to show you is actually something that I won't say that. This feature is something that is neat. However, I don't see many of you using this once you understand ISO server fully. The feature I'm going to describe is something known as network templates. Now, you just saw pretty much how to configure multiple networks for the ISO server, and we'll get into later on how we can set up permissions for those networks and what features those networks have and so on. But I mean, as of right now, you know how to set up networks, you know how to set up the rules that NAT you or route you between those networks, you know how to group them together. Web chaining, kind of a larger feature that's not used that often, but between these three tabs you can set up just about everything. I expound on this because these templates are designed for folks that don't really understand all of this. If you have an understanding of how to set up networks and rules between those networks, you'll usually prefer to do it manually. Create the networks that you want, even if you have a bigger scenario. Maybe you have 3 different firewalls you're going through, or multiple DMZs. It's a piece of cake to configure multiple networks and then set the rules going between those networks that really define your security. And before I go on, by the way, this is so much simpler than any other firewall platform I've ever seen, including the Cisco PIX firewall. I haven't played too much with Checkpoint, but this is a piece of cake to set up routing between these different networks that we have on our ISO server. If you don't get that, though, if you're a new administrator, that's why Microsoft has defined these templates for you. That, for instance, you kind of look at the picture and say, oh, I've got a 3-leg perimeter, meaning internal network here, DMZ here, internet up here. And maybe I'm a front firewall and there's another firewall behind me. Maybe I'm a back firewall, meaning there's a firewall up here and I'm the one behind it. Maybe I'm just a single network adapter and all I'm used for is caching. And you can see that they give you handy-dandy descriptions that describe each one of these, which really give you a feel for what these are used for. They're templates that are used for folks that don't know too much about configuring networks individually. So let's say you had this. Poof, you click it, and it says, welcome to the wizard, I will set you up. By walking through this, by the way, it says, warning, this will overwrite everything that you've configured on your ISO server. You might want to export your config, and you can export it to an XML file. We'll talk about export and import also in a later nugget. But you can go through here and actually start defining your internal network addresses, the perimeter network addresses. Do you see what it's doing? It's going through and saying, what do you want to do, giving you nice, simple, easy to follow steps that just about anybody could follow. Even if you don't know too much about firewalls in general, you could pretty much say, hey, these addresses are there, these addresses are there. This is the general rule that I want to follow for, limited web access, and you can get a feel for what that means down below, and hit next. And by the time you click finish, I'm not going to do this because it'll blow away all my config, but when you hit next, it will design and set up all the rules that you need to make your ISO server work for whatever design you've clicked on. All you need to do is define the addresses and the general firewall strategy you wish to use, and ISO server does the rest. That being said, and I want to reiterate, most people won't use those templates. Most people will understand what ISO server is all about, and you'll what's the way to say this? You'll prefer to define it all manually because it gives you much more control over exactly who's accessing who. Well, let's go ahead and wrap things up. This has been an awesome nugget, taking a look at how ISO server views the different networks that are around it. This pretty much encompasses the major, if I were to rule out all the features, this is the major feature of ISO server 2004. The ability to have multiple networks treated differently throughout your enterprise organization. This just gave us an introductory view to those networks. We'll get deeper into this as we go. Don't worry about that. We'll be talking about how we can define different firewall treatments, how the ISO servers see. I'm getting too far ahead. You'll see as we go through the rest of this series. What we did in this one was we took a look at ISO server's killer new feature of multiple networks. We then talked about the default networks, the internal, the external, VPN clients, quarantine VPN clients, that are all seen by default by the ISO server. Oh, and the local host, of course. Forgot about that one. We then did the configuring additional networks. We added the scandalous user as an example one, but you can configure a unlimited amount of additional networks by interface, by subnet, all kinds of different ways that we can add those in there. The network rules, if there was one thing I wanted to make sure that you grabbed from this, it was that, network rules. The network rules was the key feature of ISO server that defined how we communicate between those networks. Without network rules, you can create as many networks as you want, and ISO server will never allow communication to happen. Again, network rules defining two relationships, routing and NAT. Choose your relationship between your networks. We also, inside of all this, saw web chaining as well. Don't want to leave that one out. That's a more advanced feature we'll talk about, especially when we get to arrays. But we finally wrap things up by talking about the network templates. This being a picture of a typical DMZ three-leg perimeter network. The utility that you can use to generate ISO server's config extremely fast, especially if you're not too sure how to do each piece manually. I hope this has been informative for you, and I'd like to thank you for viewing.